Hi, today will be medical talk number 9. It will be kidney number 2, functions and anatomy. So talk about the functions. There are two main functions. One is to get rid of the waste. The number 2 is to control the volume of body fluids. So control the water level and the electrolyte composition. How much ions are inside. Ions are basically positive and negative atoms. So waste must be eliminated as quickly as they are produced because waste will toxic the environment for the cells. So as fast as they're produced, they must be get rid of. So for example, what kind of waste? You are talking about urea. Urea is from the breakdown of amino acids. Creatinine is from the breakdown of muscle wear and tear. Uric acid is from the metabolism, is from the creation of nucleic acid. End products of hemoglobin is bilirubin. So bilirubin, if it's not get rid, it will cause you to have jaundice. Jaundice means the skin will turn yellow, the eyes will turn yellow, and it's actually toxic lah. And other things like pesticides, drugs, food additives, food coloring, all the bad things will be, the kidney knows how to get rid of them lah. And so the input and output of electrolytes must be matched precisely. It cannot be too little, it cannot be too much. It must be exactly the same, right? Whatever you eat, let's say we eat salt, sodium chloride. Salt is sodium chloride. So if we eat 10 grams of sodium chloride, exactly 10 grams must come out, right? Assuming you already have enough sodium chloride in the body, it must exactly. So so that the cells can perform their various activities, because in the body must always be the same concentration. If not, the cells cannot perform. Okay, but can we eat too much? What happens if we go and eat very salty food? So actually we can eat up to 10 times the normal amount of salt or potassium or whatever, or even we eat 2 liters salt also can. Because the body, if you eat too much, the body knows how to use hormone. Within 2 or 3 days, the hormone will get rid. The hormone will tell the kidneys to get rid of all the excess sodium. And other functions is small function is like to regulate blood pressure, to regulate the pH balance. Okay, because if I'm not mistaken, below 7 pH, you will die already. Okay, so it must be what cannot be acidic And then a hormone, it creates hormone that stimulate red blood cell production. So people who got kidney disease, they are often very anemic because they don't have enough red blood cells. Then they regulate vitamin D3. So people who are also got problem with their kidneys, they don't have enough vitamin D. So as a result, their bones become very weak. Yeah, and also there's a glucose, it's a glucose storehouse in the kidney. When you are fasting, let's say at night you don't eat, and then if you are cold, so you need energy, so the kidney will release glucose. It's the same as the liver. The liver and the kidney are glucose storehouses. So okay, now we go to the anatomy. Anatomy means the physical structure. It is divided into two. If you were to cut the kidney into from the top to bottom, you will see that there are two. It's like a durian. You peel the durian, you see that there's the flesh, the green color skin, and slightly below the green color skin, that is called the outer shell. And then the inner shell is the medulla. Medulla means middle. Okay, so there is about 66 liters flowing through your kidney every hour. 66 liters of blood. And this is 22% of whatever the heart pumps. There are about 800,000 to 1 million nephrons. Okay, later we will learn what are nephrons. So each kidney has 1 million nephrons, and they cannot generate. So if they die, then too bad. They cannot build new ones. And after 40 years old, the kidney will decrease about 10%. The nephrons will die. Will die by themselves. About 10% will die every 10 years. So by the time a person reach 80 years old, only 60% of the nephrons are left. But it is not a problem because unless you are an athlete, let's say you are a sportsman, then of course you cannot have this. You won't like it. But for normal work, the remaining nephrons can do the remaining work, not a problem, because we got excess capacity. So each nephron consists of two things. One is a capillary, one is a tube. They call it tubule. A tube, a long tube. Yeah, so the waste, the blood will flow in the blood will come in from the capillary, and then the waste means the bad things will flow into the tubule. Yeah, and then later from the tubule, all the good things, sometimes got good thing inside also, the good thing will come back, will be reabsorbed into the capillary. Later I'll show the pictures lah. And then we have loop of Henle. Loop of Henle is part of the tubule. Loop of Henle is just a very long tube, which is a loop shape, and 8 to 10 tubules will form one duct. So there are about 250 ducts, and some nephrons have longer loops. So not all nephrons are the same size. Some have a longer loop. So you'll see what are the loops later. So this is a loop. This is a okay. We go through a kidney first. So the kidney, the blood will come in from the red color one, the artery will come in, and then it will go to all the nephrons, to all the 1 million nephrons, and then it will come out from the veins, from the blue color one, it will come out from the vein. So on the right hand side, so what is a nephron? So you can see a small box here at the bottom. Yeah, this is one, assuming this is one nephron, one small nephron. So on the right hand side is one whole nephron. This whole thing is considered one nephron. Okay, so the blood coming from the artery, it flows to the afferent arteriole, they call it, and then it goes to the glomerulus. This capillary is called the glomerulus capillary because glomer means like a globe, like a ball, like a globe. So a ball's capillary, the shape of a ball. So the blood will come to the ball, and then the waste will come out to the tubule. Like all the, not just waste, even salt, whatever, ions, drugs or whatever will come out. Right, and then but the blood will continue. The blood will still flow through the veins, all the red color, it will flow out, and then the blood will flow out to the veins. So what happens to all the water and all the waste in the tubule, right? It will flow, right? It will come down to the loop of Henle. When it comes down to the descending loop, when coming down that part, the wall is very thin, of the loop. So of the tubule, so some of the good things that is want to be reabsorbed, it will be reabsorbed into the arteries again, into the capillary. It will be reabsorbed into the capillary. Then when coming up, cannot already, because coming up the wall very thick, so it will just go back up. So coming down, because the pressure is very strong, and also the wall is very thin, so a lot of some good things can come back out. And then it will flow out to the cortical collecting tubule, and then it come out to the duct. So many form one duct. So at the Bowman's capsule, this is called the Bowman's capsule. At the Bowman's capsule, the waste come out through like osmosis like that. Okay, but I think it's not just osmosis. I think the cells, if you study the next, I think the next video I will do, actually their sodium, the cells is not osmosis, it's actually cellular transport. Yeah. Okay, so anatomy of kidneys. Sorry, so this is just to show the position between cortex and medulla. So you see the loop of Henle always goes inside the medulla one. Yeah. And the picture on the right, we can see there are two nephrons here. The left nephron is very little in the medulla only. The right nephron, you can see the loop of Henle very long one. Right, it goes inside the medulla. So some is very short, some is very long, just to show. And where is the medulla? So you can see the cortex, renal cortex, like a durian. This look like a durian shape, I consider. So renal cortex is here. Whereas the medulla is inside here. Yeah, so you can see the dotted line. This dotted line tells you the border. Outside is cortex, inside is medulla. So and then there are two kidneys. So the kidney is actually very small only. I think it's about 7 cm long and about 4 cm wide. Yeah, so it's only the size of your palm. It's slightly longer than the size of your palm. And yet it can filter out all the things. Yeah, so this is how the Bowman capsule looks, how the Bowman capsule works. So like I said, you know, number one is filtration. They call it filtration. So the waste come out, and water and waste and whatever, everything lah that can pass through will come out. Number two is reabsorption. So some of the good things that they want, they will take back in. And number three is secretion. So some of the bad things that didn't come out the first time, now they come out again. So then come out. Number four, go to urine. Urine. So there are four scenarios here. So the first scenario is only filtration, right? So the filtration come out and then it goes straight to urine. B is filtration and partial reabsorption. So come out and then a bit come back in. C is filtration and complete reabsorption. So come out and then all go back in. So it's useless lah. C is like you come out and then 100% come out, 100% go in. You know. D is you come out and then even more come out again. So D is for drugs. Okay, later I see here D. D is for organic acids and bases. And also drugs, I forgot to put. Yeah. So D is to maintain the pH. It's very important that they need this mechanism lah. So to maintain, because they want to control the pH very quickly, because if you eat acidic things, right, if there's acidic in your body, they must quickly change back to normal, right, to neutral. So and also drugs will go to D. C is amino acid and glucose right, because this is good thing. These are your nutrition. So come out and then come back in because they need this. Electrolyte, B is electrolytes like sodium and chloride, and A is all the waste products right, like bilirubin, creatinine. So reabsorption is quantitatively more than secretion so there is always going to be more that goes back in, then comes back out, then comes back the second time. So secretion is important to control potassium and hydrogen ions, also drugs So regulated, it is all regulated according to the needs of the body. So the kidneys know what the body needs. You don't have to tell the kidney, give me more sodium, please take out more chloride, no need. The body knows. How the body know is a subject for the next, the next class, the next talk. But because we cannot have too much or too little of anything, okay, of some of the ions and all. So it is a two-stage process. But why must go out and then must come back in? Scientists think that is because this way we move waste faster this is more efficient, and as a result, the water, the body fluid it pass through the kidney 60 times every day. So so it's very 60 times so you divide, every hour about 3 times the same blood goes through the kidney. So it is considered as efficient this way. This is nature okay. I don't know why is it like this, but it is nature. So we learn conclusion, we learn about the function and anatomy. Any imbalance of the fluid is usually due to kidney okay. So if you think, how come when you do the urine test, for example, you got protein in your urine, you got too much sodium in the urine, all this is usually due to the kidney, okay. But of course, kidney problem doesn't mean you got no problem elsewhere because kidney, heart and liver is normally linked one And so far, artificial machines like artificial kidney, dialysis machine, all this cannot replace the kidney, because the kidney is so special that artificial machines cannot replicate the process, okay. So this is amazing machine if you consider it a machine. So it is much better than a machine actually, okay. Thank you, bye.